And we did first three sums of the problem set, yes. Okay, so next is, these are the next topics that you'll be learning. First is a Venn diagram. So we'll understand first what is a Venn diagram, how to draw it, how to read it. Then what is the meaning of subset? What is the meaning of universal set and complement of a set? So this was our next concepts that we will try to finish. In our last class or before that, the concepts that we did was types of sets. So can you tell me how many types of sets are there?
5.
Yeah, what are they?
Singleton set.
Correct.
Then equal set.
Hmm.
Then empty set.
Yes.
Then infinite set, infinite set, then finite set.
Yeah. Correct. So we did 5 types of sets: singleton set, empty set, null, a finite set, infinite set, and equal sets. Now let's see what is Venn diagram. Okay, these are the two famous mathematicians who invented Venn diagram. First one was called as Leonardo Euler, and second one is John Venn. So it is under his name. It is under his name that is given to the diagram that is called as a Venn diagram, John Venn. So what he said, let's see what is his definition, how we defined a Venn diagram. So Venn diagrams, they are very useful in order to understand and illustrate the relationship among sets and to solve the example based on sets. Now, till now, whatever you studied about sets, that was just numbers. Okay, that was just numbers, just writing it. But how can you visualize it? How to imagine how this will look like? So let's see that. So that is the basic meaning of a Venn diagram. Venn diagram helps you to visualize, to help you to imagine how a set looks like. So a set is represented by a closed figure in a Venn diagram. Closed figure. Okay, what? Just give me a minute. Huh? Okay. A set is represented by a closed figure in a Venn diagram. Some of the closed figure. Now, what is a closed figure? Okay, so to represent a set, we can use a closed figure that is a rectangle. So if you see a rectangle is a closed figure. Do you understand the meaning of closed figure? That means it is covered from all sides, from all directions it is covered. Okay. Is this figure closed?
No, sir.
No, this is not. So you cannot use this figure to draw a Venn diagram. You have to use only a closed figure. That means it has to be closed from all the sides. So you can use a rectangle, a circle. So if you see a circle is also a closed figure, and you can use a triangle. You can use a triangle. Let's see examples. So if you see, this is a rectangle, and inside this rectangle, which numbers are there? Can you read it out?
1, 2, 3, 4.
1, 2, 3, and 4. So this is a Venn diagram representing the set with numbers 1, 2, 3, and 4. So this set has numbers 1, 2, 3, and 4. Or you can do it, you can represent it with a circle. So that is 1, 2, and 3. So this set has the numbers or has the elements 1, 2, and 3. Or you can use also a triangle. So that is 1, and in this triangle, there is a set, the elements are 1 and 2. Is this clear up to here?
Yes, sir. Yes, sir.
Okay, now let us understand the use of Venn diagram from the following example. So if you see this in this example, there is set A with elements 1, 2, 3, 4, and 5. So I'll denote this set by a Venn diagram and I will use the figure circle, the closed figure circle. So set A has the elements 1, 2, 3, 4, and 5. Now this you can write anywhere inside the figure. So this figure represents the set A, or this Venn diagram represents the set A. Okay, can you read this set?
B set is a variable x such that -10 is
This you read
lesser
it.
than.
No, this you read it as x is between -10 and 0.
-10 and 0. Okay, sir.
So x is between -10 and 0, and x is an integer.
Integer.
So what all elements in this set? Tell me in the listing method.
-1, -2, -3, -4, -5, -6, -7, and -8 and 9.
And are you missing anything?
Most polynomials.
Anything else?
Also,
Look at this sign here. It is greater than equal to, lesser than equal to. So there is equal to.
yes,
So,
sir.
so
Yes.
what are you missing?
0 and -10.
Minus 10. Correct. So this is your set B. This is your set B. And this you can write it in the, you can denote it using Venn diagram. So you have used a rectangle. I've used a rectangle. And this is B. And these are all the elements. You can write it anyhow. Anywhere you can write it inside the rectangle.
Okay, sir.
So is this clear?
Yes, sir.
Oh, now let's understand what is the meaning of subset. Listen to the definition carefully. If A and B are two given sets and every element of set B is also an element of set A. I'll read the statement again. A and B are two given sets. Every element of set B is also an element of set A. Then B is called as the subset of A. And this symbolically subset, the symbol for subset is this. Okay, this is the symbol for subset. So this is symbolically written as B is the subset of A. So this is read as B is a subset of A. If it is like this, suppose, if it is like this, then how will you read this? A is a subset
A
of
is a
B.
subset of B.
Okay. Now understand the meaning of this definition clearly. Okay. I'll just repeat once again. Every element of set B is an element of set A. Then
So
B
it's
is
like equal sets, right?
no. It is not really. In equal set, what happens? In equal set, all the elements of set A and all the elements of set B should be same. But in this subset, what happens is elements of set B should also be in set A. But it is not necessary that elements of A should be in B. That is not necessary. We'll do an example, you will understand. But just remember this first statement. Every element of set B is also an element of set A.
Of set A.
Or we can also say that B should be inside A. Okay, set B. So since you are writing it like this, since you're writing it like this, B is a subset of A, that means B should be inside A, or all the elements of B should be inside A. But the opposite is not necessary. That means all the elements of A it's not necessary that it has to be in B. Okay,
Yes,
we'll see one example so you'll understand it clearly. So see set A, and set A is 1, 2, 3, 4, 5, 6, 7, 8. And look at set B. Set B is 2, 4, 6, 8. Now, try to remember the statement. Every element, if B is a subset of A, then every element of B should be inside A. So you see, 2, is it inside A?
Yes.
Yes. 4, is it inside A? Yes.
Yes.
6 is also inside A, and 8 is also inside A. So all the elements of set B is inside A. So B is a subset of A. But if you see, the opposite is not correct. Okay, all the elements of A are not in B. Some are there, but not all. Okay. So you cannot say A is a subset of B. Can I say this? No.
No, sir.
You cannot say, because definition, what it says, every element, all the element of B should be in A. Then only you will say that B is a subset of A. Clear?
Yes, sir.
Okay. Now this can also be said as, this B is a subset of A can also be said that B is inside A. Okay, B is inside A. Now let's try to understand this by the Venn diagram. So this is set A, and this is set B. So can you see set B is inside A? Set A has all the elements 1, 2, 3, 4, 5, 6, 7, 8. This is set A. But set B is only this white portion. That is 2, 4, 6, and 8. That is only set B. And if you look at the diagram, set B is inside set A. So B is a subset of A. So as we say subset, so it is inside A, that is why subset. Is this clear? Is this example clear? Any doubts in this example?
Sir. Yes.
No. Okay. So 2 statements to keep in mind. If B is a subset of A, every element of B is an element of A, or we can say that B is inside A. So this to keep in mind. Okay, let's see some more subsets. N is equal to set of natural numbers, and you know what are set of natural numbers. I is set of integers. You know what are integers, correct? Negative and positive numbers. Okay. Can you tell me what will be the subset of which? Try to write it. N starts from? Unmute yourself. Unmute.
1.
Yeah. So 1, 2, 3, 4, and so on.
4 and dot.
And then I?
It starts from -1.
Put dot, 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 dot.
Yeah, dot.
-1, 0.
-1.
1,
Dot.
2, 3, and so on. Now tell me, is N subset of I, or is I subset of N? Tell me which is correct and which is wrong.
N is subset of I.
Yes, N is subset of I because all the elements of N are inside I. N is inside I. So we can say that set of natural numbers is a subset of set of integers. Clear? So N is a subset of I because all natural numbers are integers. Okay, let's see the second one. Can you read this set?
So P set is a variable x such that x is square root of 25.
So which element in this set in listing method, can you tell me? Square
Listing
root.
method.
In listing method.
5.
Yes. Any other?
1.
It has to be square root of 25.
No, it's only 5.
Are you sure? Only 5?
And 25 and 25 and 25.
No. It has to be square root. Square root of 25 is not 25. Square root. Square root of 25. That means this. 1, you said 5 is correct. Is there any other number possible? Is it possible? No. So it will be singleton. Singleton. Okay. Look at S. Can you read S?
Yes, sure. A set S is such that y belongs to integer. Y is between -5 and 5.
Okay, now it is an integer and it is between -5 and 5.
5 and
so which other integers between -5 and 5?
-5, -4, -3, -2, -1, -0, 1, 2, 3, 4, 5.
Correct. Now, what is a subset of what? Is P subset of S or is S subset of P? Can you tell me? Which is correct? Is this correct or is this correct?
It's a subset of S.
P is a subset of S. This is wrong. Okay, so P is a subset of S because P is inside S. Clear? Okay. Now remember this. Just give me a minute. So remember this, every set is a subset of itself. Okay, every set is a subset of itself. So A is a subset of A. Second point is also a very important point. Empty set is a subset of every set. Okay, empty set, it is a subset of every set, any set. And third one, this is also very, very, very important point. Okay, this one. If A is equal to B, that means if they are equal sets, then both is true. Then you can say A is a subset of B, and also you can say that B is a subset of A. Both. But this you can say only if A and B are equal sets. Then only you can say this. Okay?
Sure.
Are these 3 points clear? So first one is every set is a subset of itself. Second one, empty set is a subset of every set. And third one is if two sets are equal, that means if A and B are equal, then A is a subset of B and B is a subset of A. Clear? We have one more point, fourth one. Fourth one is the opposite of the third point. So third point said that if A is equal to B, then A subset of B, B subset of A. Fourth says that if A is a subset of B and B is a subset of A, then both of them are equal, A equal to B. So these are two opposite points. Okay, so if A is equal to B, then A is a subset of B and B is a subset of A. Or if A is a subset of B and B is a subset of A, then you can say that A and B are equal sets. Okay, are these 4 points clear? Yes. Are these 4 points clear?
I think I was lagging because I couldn't hear you for one second.
These 4 points, are they clear? Any doubts in 4 points?
No, sir.
Okay, so we'll move on to the next. Continue. Okay, so the next concept is universal set. So let's understand what is a universal set. A suitably chosen non-empty set of which all the sets under consideration are the subsets of that set, then that set is called as a universal set. Okay, I'll repeat it. You may not understand the definition at once, but when we solve more examples, you will get a clear picture of what is exactly a universal set. So a suitably chosen non-empty set. Okay, non-empty set means something has to be inside it. Non-empty set of which all other sets should be a subset of that main set. Okay, so one, you have a main set and rest all the sets should be subsets of your main set. Then that main set, you call it as a universal set. Okay, it is a main set. Usually universal set is denoted by the letter capital U. Okay, so whenever you see a set which is denoted by capital U, it is usually the universal set. I'll repeat the definition. A suitably chosen non-empty set of which all sets under consideration are subsets of that set, then that set is called as a universal set. Universal set is usually denoted by the letter capital U. Let's see more examples so that you may have a better understanding. So let's see this example. Can you read this?
Yes, sir.
Yeah.
Set A such that X is physics laboratory in your school.
Okay. Next.
Set B is such that Y is chemistry laboratory in your school.
Next.
Set C, the variable Z is such that Z is biology laboratory in your school.
Okay, now if you note one thing, these are all 3 different sets. So A is a set of physics laboratory, B is a set of chemistry laboratory, and C is a set of biology laboratory. Can you read the set U?
Set U is denoted by the variable L, such that L is laboratory in your school.
See? Okay, please if the meeting ends, just rejoin, okay? Okay, so see this, biology laboratory will be in this. See, U is a set of laboratory. It can be any laboratory. Okay. So biology laboratory will be inside U. Similarly, chemistry laboratory will be inside U, inside the set of all laboratories. Even physics laboratory will be inside your set of all laboratories. So if you see, this is your main set. Okay, this is your main set. And rest all is a subset of this set. So A is a subset of U. Even B is a subset of U. Also, C is a subset of U. So this is called as a universal set, and rest all the other sets are subset of your main set. Is this clear, this example?
So,
now, this is a very important point. Universal set is a set that cannot be changed once fixed for a particular solution. Okay, so if you have fixed a universal set, you cannot change it later on. Okay, so it cannot be changed once fixed. In Venn diagram, and now this is also very important. When you draw a Venn diagram, a universal set is usually represented by using a rectangle. Okay, and rest all subsets are used by circle. Okay, so this is a notation that you follow. A universal set, you represent it with a rectangle, and rest all subsets of the universal set, you denote it by a circle. Okay. Next, we'll see complement of a set. What is a complement? So we studied two things, two main things. First one was subset. Second one was universal set. Okay, so you know, for subset, if A is a subset of B, then every element of A should be in B. Now let's see universal complement of a set. Suppose you have a universal set U. U is a universal set, and if B is a subset of U, that means B is inside U. All set of all elements in U. Then set of all elements in U which are not in B. Okay, listen to the words carefully. Set of all elements in U which are not, okay, which are not in B, that is called as a complement of B. Okay, set of all elements in U which are not in B, that will be called as a complement of B. And usually B complement is denoted by this letter, that is B dash, or we write it B raised to C, where this C represents complement. Okay, we'll do an example so that you may understand. But keep this statement properly for complement. So the set of all elements in U, that is a universal set, which are not in set B, that is called as a complement. So B is defined such in a roster method. Sorry, in set builder method, we write B complement like this. Set of all X that belongs to a universal set, but not in B. Okay, this has to be B complement. Is this clear? Unmute yourself and talk.
So could you explain again, sir? I can't.
Complement.
Yeah, complement of this.
Okay. I'll explain it to you in this example. So if you see, don't look at this. Okay, don't look at this. Just look at the universal set U and look at set A. is A subset of U? Yes.
Yes, sir.
Yes. Now, how can you tell that A is a subset of U? Because all the elements of A are in U, correct? So 2,
Yes, sir.
2 is there. 4, 4 is there. 6, 6 is also there. 8, here 8 is also there. 10, 10 is also there, correct? So all the elements of A are in U. Now, can you see some elements in U which are not in A?
Sir.
Which are those elements? Can you
1,
tell
3,
me?
5, 7, 9.
1,
1,
3.
3, 5, 7, 9.
This element, this set is called as A complement. So elements in the universal set, not in A. Understood? Is this picture clear now? Complement? Yes or no? Unmute, unmute. Yes?
I understand, sir.
Okay.
Yes,
So
sir.
you have to keep this statement in mind. Complement of a set, suppose if it is a set A, then all the elements in the universal set which are not in A. So that is the definition that says here. If B is a subset of U, then set of all elements in U. So U, keep in mind, U is universal set. So set of all elements in U which are not in set B is called as a complement of B. So that was very clear from this example. So you see all the elements in the universal set, not in A. So if you see, this is set A, that is having the element 2, 4, 6, 8, and 10. And this is a universal set. This entire thing, okay, this entire thing is a universal set. And just this circle is your set A. And outside this circle, what is there? Outside the circle, that is this portion, that is your A complement. Did you understand this Venn diagram properly, clearly? Is it clear?
Yes, sir. Yes, sir.
I'll just repeat it once again. Or rather, we'll draw it like this. The universal set that will have all these elements correct. This is my universal set having all the elements. This, I'll draw a circle here. Okay, this is not a proper circle, but this is my set A. Correct? 2, 4, 6, 8, and 10. This is my set A. And all the elements outside A. Okay, that is this. Okay, this will be your A complement. Okay, this will be your A complement. Clear now? Okay, the meeting will end. Just
Yes, sir.
rejoin. Okay, rejoin.
Okay, sir.